Guys, I just realized that when I shot the video that it was a little bit blurry. So I'm just going to go quickly over the problems, and you can actually stop the video or go back to the section that you need to read. So here is the first problem that I went over. Okay. So you can go back and freeze the video to see that problem. Okay, I'm going to show you the second one. The second one is that. So again, you can go back to this section when you're looking at the problem that I'm going to talk about, and freeze it. Here's the third one. Fourth. And the last one. Guys, I decided to do some more examples of the center of mass so that hopefully you'll have a better understanding. But the way I think of the center of mass is a distribution of mass. So if I have a mass here, let's say 1 kilogram, and I have a mass here that's heavier, 5 kilograms, okay, and one dimension. So the center of mass is closer to the 5 kilogram than it is to the 1 kilogram. So I can think of both of this as one mass that's 6 kilograms, and it's located right at this section, at this position here. Okay, that's pretty much how we define the center of mass. So I'm going to do some examples from the AP classroom. So I have this picture here, okay? And the question is asking you, they're telling you all that stuff. So they're telling you what will happen to the center of mass? In what direction will it move? And what is the magnitude of the acceleration of block X or block Y, which is the same thing. The acceleration I'm not going to do. You should be able to do that using dynamics. Right, F net equals ma, but I'm going to talk about the center of mass. So I'm looking at this picture here, and I can tell you that the center of mass is kind of closer to 2m. So maybe it's kind of like here-ish, let's say, right? I exaggerated that. I have no idea, but we can do the math later when we do center of mass, and then we can figure out exactly what it is. Well, if you think about it, this object accelerates this way, right? Or moves this way. It doesn't have to accelerate, so it moves this way. Okay, so the center of mass has to shift to the right, but this one also moves down. So I think the center of mass keeps on shifting right and down. That's where the center of mass is located. For the acceleration, I think you can figure that out on your own. Let's take a look at this example here. So the center of mass here should be closer to the 3m. So here's my center of mass. And the question for this one, after you read it, you can pause the video. How does the acceleration of the center of mass of the system compare to the acceleration of mass m? Well, mass m or mass 3m, they both accelerating at g, right? The center of mass has a mass of 4m, okay? So the only force acting on this whole system is the force of gravity, right? So the center of mass will be influenced by that force of gravity. So the acceleration of the center of mass will also be just g. There is nothing else, no other forces. Okay? All right. This one here, so there is a dart going up, a potato falling down, and it's going to hit it. And the question is to look at some graphs and figure out which one looks like the velocity versus time for the center of mass. Well, let's think about that for a second. Okay. So the center of mass is closer to the potato. The potato, assuming it's heavier than the dart, so it's going to be there, right? Now, as the potato is falling, the dart is coming up. The center of mass is falling down because the potato is falling down, and the center of mass of the potato by itself, right, or the mass of the potato is heavier. So this center of mass is going to find itself just falling down. The only force acting on the center of mass is really just the force of gravity. Okay, what would be the mass of the center of mass? Well, it's basically the mass of the potato and the mass of the dart combined. So the velocity versus time graph, you should be able to figure that out, because that's basically the acceleration, right? So based on kinematics, you should be able to do that. All right, this one here, it says two spheres are there. Which of the following prediction is correct about the motion of the center of mass of the two sphere system? So here are the questions. You can pause the video and look at them. So they're asking us what's going to happen to the center of mass. How is it going to behave? Well, let's take a look. So I'm going to keep that dot in there. So the center of mass is closer to 2m than it is to m. Now, it says they're just floating there in the absence of external gravitational forces. Now we know from Newton's third law that, and we're going to learn that in the next unit also, that this mass exerts a force on that mass, and that mass 2m exerts an opposite force on m, right? Those are internal forces. They don't qualify for the F net equals ma. So the center of mass, technically, which has a mass of 3m, doesn't experience any external forces, right? So its acceleration should be 0, because there are no external forces on it. And if its acceleration is 0, you should know how it's going to behave if it was at rest to begin with. All right, this one here, and this is the last one. So you have, I should have left that. Okay, you have two masses attached by a spring. You kind of cut, and the string also. You're going to cut the string, and they're going to go boom, flying in opposite directions. And the question here is, which of the following statements are true about the motion of the block immediately after the string? Okay, well, I'll show you the answers. You can pause the video to watch them. And I'm just going to talk about the center of mass. Okay, so the center of mass is closer to 2m. So let's say that's the center of mass, and it has a mass of 3m. So in other words, I'm going to take those two and combine them into one. And they're telling us that the spring has negligible mass, so we can ignore the mass of the spring. Now, when the explosion happens, really there is no external forces acting on the whole system. The only interaction is an internal interaction between the spring and the two masses. So there is no reason for the center of mass to change its motion or to accelerate, okay? And based on that, I think you should be able to answer the questions that I showed you, like, a couple seconds ago. All right, thank you.